Hey guys, so here's some help with homework assignment on projectile motion. This is problem number 1. We didn't do one like this in class, but we can figure it out. It says use the parametric equations, and these are on your formula sheet, to solve the following problems. Number 1, the left field fence at a baseball park is 400 feet from home plate and 8 feet high. A baseball is hit from 2 feet high with an initial velocity of 150 feet per second at an angle of 25 degrees with the horizontal. Part A says write a set of parametric equations that model the path of the baseball. Part B says, is the hit a home run? Justify your answer. So if you look at this problem, the first sentence, it says the left field fence at a baseball park is 400 feet from home plate and 8 feet high. This first sentence is only going to help us answer part B. To answer part A, we just need the second sentence. So I'm going to highlight that. So it says a baseball is hit from 2 feet high with an initial velocity of 150 feet per second at an angle of 25 degrees with the horizontal. See if you can make a list of all the variables that are given in this sentence. Hopefully you came up with this list. Now all we have to do is plug these numbers into the parametric equations. So go ahead and do that. Okay, so here are the parametric equations that we get. Let me tell you a couple of things that people commonly mistake. People always forget this t right here. For some reason you get caught up in writing, making sure that these numbers are correct, and you forget to type in this t when you type into the calculator. Also, again, up here on the x, people forget to type in that t. Another common mistake is people forget that this is 25 degrees, so you have to make sure the mode in your calculator is in degrees. Okay, now that I've explained a couple of things to watch out for, let's go ahead and type this into our TI calculator. Again, go to mode, make sure you're in parametric mode, also make sure you're in degree mode. So we then go to y equals, and let's type in our equations here. I don't really need these parentheses as indicated in the formula, so I can just go ahead and type 150 cosine 25. Make sure, here's another thing people forget, make sure you close the parentheses after the 25 before you type the t, because we want to take cosine of 25 degrees, not cosine of 25t. Under y1, we need to type in negative 16 t squared. This represents the pull of gravity. Now we need to add 150 sine 25. Close those parentheses. Don't forget the t. And then we add our initial height, 2. Make sure that you've typed this correctly into your calculator. Now let's talk about the window. Remember, T min and T max. The best way to think about T is time. How long is it going to take for this baseball to go? Obviously, I always want to start time at 0 when I'm talking about situations like this. Usually time can go between 5-10 seconds. I'm going to type in 5. T-step. This is very important. T-step, remember, that's what we're counting by. Usually in the tables that we did in our previous homework, we counted our T-step by 1. Every second we recorded a point. But when we talk about this baseball is moving really fast. And if I count every 1 second, it's probably not going to give me enough points. So I'm going to count every 0.05 seconds. I could do smaller. Remember, if we don't like this window, we can always come back and readjust. In the x direction, this is horizontal, or how far. We want to start at 0. And thinking about the problem, it said that the left field fence at a baseball park is 400 feet from home plate. So assuming home plate is 0, where we start, we definitely want to see more than 400 feet. So I'm probably going to do maybe 450. This might not show me the whole arc of the ball, but again, we can come back and readjust. And just to make it nice, we can count by 10s or 50s. Y minimum. The Y direction. This is our vertical direction, our vertical direction. I really don't care about the ball in the ground, so I'm going to start at 0. And I want to think about how high this ball might go. It's a baseball. We're trying to see if it's a home run. So I definitely want to do more than 8 feet. Let's try, let's do 100. See what happens. And count by 10s. So let's go ahead and graph. So here's the path of my ball. Now again, I can't see the full arc. I can't see the ball hitting the ground. So maybe I want to add more x values over here. I want to see more. So I need to increase my x maximum. Because this, right here, this point, that's the x max right now. It's not good enough. I need more. The y seems to be okay. You could maybe lower it, but it seems